Morning, grade ninths. We are going to press on and we're going to start section 7.3 today. I know I said we'd take a break and we were going to do something a little different, but I've had a change of heart. We're going to press through and we're going to do the next two sections, then we're going to take a break and do something a little different. Okay, so section 7.3 is called similar polygons, so we need to do a bit of a review. First of all, we need to talk about what is a polygon. So polygon is a closed shape with straight sides, okay? That's important. And the two sides need to meet at a vertex, which is basically just like a corner, we could say. Okay, so this shape is a polygon because you can see it's got straight sides and it's closed. This would be an example of a non-polygon. It's closed, but we have a curved side here, and that makes it not a polygon. This one's got the straight sides, but it's not closed, so therefore not a polygon. Okay, so if we quickly went through this, and I said, is it each shape a polygon or a non-polygon? I would have had you do this in class while I was at the board. Okay, check mark or a Y for yes. Polygon, not a polygon. It's got straight sides, but it's not closed. We would put an X there. This one's got a curved side. No. This one is a polygon. Okay, it's a weird shaped polygon, but it's still a polygon. It's got straight sides and it's closed. This one is not closed. You can see it extends here, not working. And this star is indeed a polygon. Okay, so that's something that you need to know. The other word that shows up in this section is similar. And similar in this situation is different from the way we'd use similar in everyday conversation. Similar when we're talking about polygons or triangles in the next section doesn't mean that they kind of look the same. Like we could say those two boys look similar because they both have brown hair and they're 5'10". Okay, that's not how we work in math. When we say one polygon is similar to another, it means that it's an exact enlargement or reduction. So we're staying with scale factor here. This is an extension of scale factor. So two polygons are similar when their matching angles are equal. So corresponding or matching angles are the same. And we can see this in this situation here. Even though we haven't been given the size of the angles, you need to remember that this means that this is congruent to this side. And then when we want to show congruency again, we use the double. Okay, we know that these are both 90-degree angles, so those are similar. And now we've used this little dot. Okay, and so that's a congruency symbol. So it's past the first test, which is that the matching angles are equal, but you can see it's capitalized here, and the matching sides are proportional. And we should remember for our last two sections, if something is proportional, that means the same scale factor. Okay, so let's do a quick example here. Remember, it has to satisfy both of these characteristics. Okay, so are these quadrilaterals similar? So here we go. They're sitting in the same location. So that's another thing that might come up a little later in this section, is that you might have to recognize that the shapes are turned a different way and you have to set them up and take a look at them when they're sitting in the same situation, I would call it. Okay, so the first and easiest thing to do is to take a look at the angles. So here we have a 90-degree angle, and the matching or corresponding angle is exactly the same, 90 degrees. Okay, the next one I take a look at is this pointy one down here. This one's 45. This one's 45, and up here angle R is 135, and its corresponding side is 135. So rule number one, matching angles, check. Rule number two, and this is where your scale factor comes in, okay? So what I usually do is whichever one comes first, I call the original, and then I call the other one the scale, okay? So here's the orig, and here is my scale diagram. Now you can do it the other way as long as you stay exactly the same. Remember that if you call this one the original, then this one's an enlargement, and you'd have to remember that. Okay, so now we're going to remember and refresh our memory about corresponding sides. So if I were to check out QR, the corresponding side to that is UV. Okay, so I remember that I find scale factor by placing scale over original. So in this case, I would put 1, and then I would divide it by 1 5/10. Okay, and I certainly don't mind if you use a calculator if you wanted to. It's really not a big deal to me in that situation, but you should get basically 6/10 repeating. Now, if these are similar quadrilaterals or similar polygons, what we're going to see is that each and every time we figure out scale factor of a corresponding side, we're going to get 6/10 repeating. Okay, so I should have been more organized here and had different writing utensils. I'm gonna try and do this in a different color. Everyone should agree with me that QT is a corresponding side to UX, okay? So again, I'm gonna go scale over orig, And I really should be writing the letters to the sides. I'll do that in the next one. So in my scale diagram, I had 2. In my original, I had 3. And again, if you divided those, you get 6/10 repeating. So far, so good. Okay, but we're going to check every single one of them this time. I'm just going to reach for another color here. Okay, so here's my corresponding side RS, and that corresponds with VW, scale over a ridge. So now I have scale diagram is 2 8/10, and the original is 4 2/10. And when I divide that, guess what happens? Want to be quite sure. And you'd know that you have set something up wrong maybe if you got a different answer. It seems to be working out. They might not be similar, but you might have put original over scale. So you always go back and check that first to see if that's the error that you made. Okay, and now I've got no other color here, so I'm just going to tell you that these are the corresponding sides. Scale over original. So now we have, I always write this down because I like to remind myself. Now I have 3 over 4 5/10. And if we work that out, guess what? We got 6/10 repeating. So that satisfied characteristic number 2. All the sides in this polygon are proportional, or we could say have exactly the same scale factor. Okay, you could describe it in both ways. That means exactly the same thing. So these indeed are similar triangles. So they might look the same, but you might encounter a situation where the corresponding angles are the same, but maybe when you check the scale factor, they're not. So you have to be aware of how to do that. Okay, we are at 6 minutes and 44 seconds. Okay, I'm going to send you a copy of these notes, and I would like you to try the scale factor down here. I'll have a second set of notes where I've done everything for you to prove that they are corresponding, or angles and corresponding sides are proportional. And then I'm going to put up an assignment today in the Google Classroom, and it will be in the classwork section, not just on the stream. Okay, talk to you soon.